Hi all, this is a YouTube Tryout lab submission from Team CodeBreakers, that is Group 4 for CompE 285, that is Software Engineering Processes under the guidance of Professor Richard Zinn. We will be discussing about agile methodologies. First of all, let me introduce you to the team members of Team CodeBreakers, that is Group 4. Myself, Vimanyu Agarwal.
Hi guys, Kaushal.
Hi everyone, this is Nirmali.
And as discussed, this is the YouTube Tryout submission from CompE 285. So let's get started.
We'll start with agile development. We'll start with a quick overview. The first question that comes into our mind is that what is agile software engineering? Agile software engineering, it combines a philosophy and a set of development guidelines. The philosophy, it encourages customer satisfaction and early incremental delivery of software. There's a small, highly motivated project teams, they have informal methods, there's minimal software engineering work products, and overall development simplicity. The development guidelines stress delivery over analysis and design, and there's active and continuous communication between developers and customers. Next question is that why, who does it? Software engineers and other project stakeholders will work together on an agile team, a team which is self-organizing and is in control of its own destiny. An agile team it fosters collaboration and collaboration with all who serve it. Then why is it important? The modern business environment with strong computer-based systems and software products is fast-paced and ever-changing. Agile software engineering represents a reasonable alternative to conventional software engineering for certain classes of software and certain types of projects. It has been demonstrated to deliver successful systems quickly. Then, next question that comes into our mind is that what are the steps to implement it? The agile development might best be termed software engineering light. So the basic framework activities which are communication, planning, involvement, construction, and deployment, they all remain as is. But they just morph into a minimal task set that pushes the project team towards construction and delivery. Then what is the workaround? Both the customers and the software engineer, they have the same goal. The only really important word product is an operational software increment which is delivered to the customer on the appropriate commitment date. Next, we move on to the agility principles. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. We welcome changing requirements even late in web development. Agile processes, they harvest change for the customer's competitive advantage. Deliver working software frequently from a couple of weeks to a couple of months with a preference to the shorter time scale. The business people and developers must work together daily throughout the project. We need to build projects around motivated individuals, give them the environment and support they need, and trust them to get the job done. The most efficient and effective method of conveying information to and within a development team is face to face conversation. Next is working software is the primary measure of progress. The agile processes they promote sustainable development. The sponsors, developers, and users should be able to maintain constant pace indefinitely. There's continuous attention to technical excellence and good design enhances agility. Simplicity. That's the art of maximizing the amount of work not done is essential. The best architectures, requirements, and designs emerge from self-organizing teams. And the last one is that at regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. Now we'll move on to Sparsh, and he's going to speak about Scrum methodology.
Hi guys, so I'll be speaking about Scrum framework. So one of the features is that developing work is partially repetitive. This is because so that we could have more frequent additions to the product in short cycles, which would enable us to just have more enhancements on our product and in a short iterations. But this to debug additional bugs on the so that fix on the bug and make it very late, which might cause a lot of chance to the initial code base. So we have split work divided into sprints. So the sprint is normally of 2 to 4 weeks. So it could take from duration of 2 weeks and go up till the 4 weeks typical. And we have these very short startup meetings every day in the Scrum framework, and these meetings are normally 40 minute durations to the maximum. So that's why that's called as startup meetings. And as improved functionality comes in sprint that was continuously achieved, even though the functionality has not been even the functionality was not planned initially, but it incorporates all the functionality that has been achieved during the sprint. So now I'll be explaining the Scrum framework diagram, which pretty much covers all the components that we have in the Scrum framework. So, so the first component you can see over the diagram is product backlog. So product backlog is managed by the product manager. So it is basically a list of prioritized requirements that are demanded by the customers. They have dailies that normally has been released by every customer. So from this product backlog, we pull off items in each and every sprint and then incorporate into the sprint backlog. So sprint backlog are the list of items that they can deliver within this particular sprint. So all the tasks are taken into the sprint backlog to contain the sprint. Now, within the sprint, as I said, it is of duration of 2 to 4 weeks. So we collectively work on the respective tasks and we have daily scrum meetings on a cycle of 24 hours, which are typically 15 minutes, as I just said. And normally the sprint meetings are headed by the scrum master and are headed by the scrum master, and the agenda of these meetings are normally to discuss which are the impediments that the team is facing and what has been achieved since the last meeting and what team members planning to achieve until the next meeting. So we get a pretty good idea of how the work is being done and how it's being planned so that we could achieve our within a planned manner. So now, so after the 2 to 4 week period, we have some potentially support product where the user is communicating with the client, they are meeting with the client, and we could get the feedback from the client that is the work is working is up to the requirements, up to the required standards, and we could just work on them if required further. So now this is how the Scrum framework and we are doing this framework are all extremely well, and so have implemented over there.
Hi, this is Vimanu, and I'll be discussing about extreme programming, which is also known as XP. Extreme programming is the most widely used approach for agile software development. It was made popular by the seminal work done by the Kent Beck. Extreme programming uses the object-oriented approach and establishes a set of rules and practices that occur within the context of four framework activities, which you'll be going to see now. The first one being planning, the next one design, then coding, and then testing. So first of all, let's discuss about extreme programming or XP planning. Extreme planning basically means that it begins with requirement gathering to understand the business requirements and get a broad feel for required output and major features and functionality. It is also known as planning the game. So essentially, it begins with creation of user stories. Then the agile team assesses each story and assigns some points, which is also known as the cost. The cost basically associates how difficult the task is as per the agile team. So the difficult the task is, the more the points that specific user story gets. So once all the stories are assigned the point, the stories are then grouped for a deliverable increment. A commitment is made on a delivery date. Once the delivery date is decided, it cannot be changed and it cannot be rolled back. After the first increment, the project velocity is used to help define the subsequent delivery dates for other increments. The project velocity basically means that how fast the project is going to end, and we use the first increment as the baseline for that, for defining the project velocity. The next comes the XP design. XP design recommends a few principles, first of them being the KISS principle, that is keep it simple principle. It recommends that simpler design is always and always preferred over the complex requirement. Then XP also design also encourages the use of CRC cards. CRC cards for following are used for following good object-oriented practices. It also recommends that when a difficult design problem is hit, we should use the creation of spike solutions. Spike solution is essentially a design prototype, and uh, when it is implemented, the intent is to lower the risk, and when the true implementations are starts and to validate the original estimates of the story containing the design problem. Extreme programming also recommends refactoring, which is an iterative process of refining the internal program design. Essentially, refactoring is a process of improving software systems in such a way that it does not alter the external behavior of the code, yet it improves the internal structure of the code. The third framework is extreme programming coding. It recommends the construction of unit test cases before the coding commences. That is, all the unit test cases should be completed before any actual coding starts. And essentially, this recommendation of extreme programming coding practices follows the test-driven development approach. XP coding also encourages pair programming, which essentially means that two developers will be coding side by side on the same workstation. One of the developer will be essentially doing the coding part. The other developer will be shadowing the first developer, and looking after that, the first developer is following all the objective oriented approaches, making all the right design decisions. That is, the second developer will be responsible for the holistic design approach, and while the first coder will be doing the actual coding. Then comes the XP testing. It recommends that all the test cases are executed daily. Acceptance tests are being defined by the customer and executed to assess the customer visibility functionality. So these were the four core paradigms for extreme programming. This is a snapshot summary for extreme programming. As I discussed, it contains four essential parts: planning, design, coding, and testing. Uh, it is important to know that that refactoring falls in the coding part, and it is an iterative process, while the planning includes the user stories, values, and acceptance tests criteria, and as well as the iteration plan. All the design parts, that is the use of CRC cards and spike solutions, developing all the prototypes, fall under the design. The coding we includes refactoring as well as the pair programming, and all the testing should be done by the continuous integration jobs, may be used by Jenkins. And the testing phase also includes acceptance testing, and afterwards a product increment is released and the product velocity is computed, which is used as the baseline for the next releases. So this was extreme programming. Now I'd like to hand over to Shreyams for discussing the dynamic system development method.
Thank you very much for the explanation. I'm going to talk about dynamic systems development method. Promote. This is promoted by DSDM consulting. DSDM has the following distinguishing features: similar in most. It is similar in most aspects to XP and oriented programming. It is aligned with the guiding principles. Active user involvement is imperative. DSDM teams use the cloud to make decisions. The focus is on frequent review of products. Fitness for business purpose is the essential criterion for deliverables. Iterative development is necessary to converge on an ultimate business solution. Small changes may be volatile and useful. Requirements are baselined accordingly. Testing is implemented without the reset. The continuous system development method is an agile software development approach that provides a framework for building and maintaining systems which meet tight time constraints through the use of implementing and prototyping in a controlled project environment. The design philosophy is from a methodology of end-to-end principle. 80% of the application and implementation of the effort takes to deliver the 20% of the application. Business development is an iterative software process in which each iteration follows the 80% rule. That is, only enough work is required for each increment to facilitate movement to the next increment. The remaining can be corrected later when more business requirements are known or changes have been requested and accommodated. The BSDM consortium is a worldwide group of development entities that collectively take on the role of keeper of the ledger. The consortium maintains the management process model for the BSDM life cycle and begins with a feasibility study that studies basic business requirements and constraints and is followed by a business study that identifies functional and technical information requirements. BSDM then defines three different types of types. The first one is functional model integration. Functional model integration produces a set of implemented prototypes that demonstrate functionality for the customer. The intent behind the iterative cycle is to gather additional requirements and eliciting feedback from users as they exercise the model. The second one is design and implementation. Design and implementation mainly uses prototypes built into the functional model iteration to ensure that each has been considered in a manner that is required to provide operational business values for end users. In some cases, the functional model iteration and the design and build iteration occur concurrently. The third one is implementation. Implementation bases the latest software component on operationalized prototypes into the operational environment. It should be noted that the implemented delivery may not be 100% complete, or changes may be requested as the implementation progresses. In either case, BSDM developers work continuously to iterate on functional model integration. Next time we will discuss about the BSDM development process. The BSDM development process consists of several phases. The first one is before the project is officially started. Then come the project studies, which are basically stages present in the project. Then there are two more phases that consist of iterative cycle, which are repeated when necessary to complete the task. Then there is the post-project phase when the project is done. The project flow may go between the different phases in the direction indicated by the diagram. The dark blue curves, as seen in the diagram, indicate the normal forward direction of the project flow. The green arrows indicate directions in the linear flow as necessary under normal circumstances. For example, if the team is finished designing the integration, but the system cannot be implemented or its functionality has been reviewed, the project flow may go back to the functional model iteration to complete the update. The lighter arrow represents a direction is only only taken if the project has been found to not meet the required functionality. Now coming to the pre-project phase. The pre-project phase is not strictly defined and occurs before the project has official completes. In this case, the project is conceptualized and the decision is made to start the project. Feasibility study finding out if and how the project will work. In this phase, the team researches the question, determining the constraints of time, effort, and resources. This phase is done as quickly as possible because the BSDM is invested and the time is short, and therefore the project needs to be delivered quickly. The functional model. In this case, the functional prototypes of the system are implemented quickly. A functional prototype is a prototype of the function the system should perform and how it should be how it should perform. Prototyping follows these steps: investigate, define, test. the system, designs, usability, performance optimization, and technique. The design and delivery. We will stress the product is designed and developed in-house. The execution in the field model is relatively unpredictable. We do not guarantee stable quality. We do not provide guarantees. In this next phase, the product is adapted. Documentation critical to the manufacturing is journey. Preparing the environments, real fulfillments in the product. The users of time and how to use the system and maintenance of the system. Project maintenance. After the product is created, maintenance is where to be performed. This maintenance is generally done in a cycle similar to the what used to develop the product. So that's it about the dynamic systems development method.
So guys, this was a short video covering concepts of agile methodology. Well, this methodology is widely used to manage IT projects. So hope you guys got a good overview of it. And if you have some queries, please leave in the comment section and don't forget to subscribe. Thank you.